Welcome back to online session. The topic is all pairs shortest path. Another name for all pairs shortest path problem is Floyd-Warshall algorithm. Students, in this session, we will briefly discuss about what is meant by all pair shortest path problem. What is the main objective of all pair shortest path problem? How to solve all pair shortest path problem by using the principle of dynamic programming in this session. Students, this is one of the important concept or topic in fourth unit of design and analysis of algorithms. So listen the steps carefully what I applied in this session. You have to follow the step-by-step procedure and finally you will be able to solve the problem in a easy manner. Okay, right? The problem is all pair shortest path problem. In examinations, they may ask solve the given problem by using Floyd-Warshall algorithm. All pair shortest path problem in the sense it is the problem which is used to find the shortest path or distance between every pair of vertices in the given weighted directed graph. Let us discuss the problem with a simple example. Consider the example. The given example, there is a graph. The graph is called as a weighted directed graph. Why I am calling this is a weighted directed graph? Because each and every vertex are well connected to arrow marks with a cost of something. So that means that the given graph is to be considered as a weighted graph and there is a direction between one edge to another, one vertex to another vertex. That's why we can consider this is the weighted directed graph. From the given graph, we need to find the shortest path or distance between every pairs of vertices. Listen carefully. We need to find the distance between every pairs of vertices. Pairs is nothing but it is a combination of two vertices is called as a pair. 1 to 2 is a pair. 2 to 3 is a pair. These are considered as a pair. That means that every pair of vertices in the given graph, we need to find the shortest route or shortest path or shortest distance. So hence, here the first step is the graph, convert the graph distance values into a matrix form. You need to create a matrix or you need to prepare a matrix based on the values are weighted from the given graph. So here what is the size of the graph? The total number of vertices in the given graph are 4. Hence the size of the graph, the size of the matrix is 4 by 4. 4 by 4 is the size of the matrix. That means that 4 rows and 4 columns. And we need to place the distance from one vertex to another vertex. Arrange the values in the given matrix order. So here we need to find the distance from D0 is nothing but there is no intermediate vertex. There is no intermediate vertex. Find distance of 0 is nothing but we need to prepare a matrix with initial distance values. Prepare a matrix with initial distance values. So here 1, 2, 3, 4, these are rows, and 1, 2, 3, 1, 2, 3, 4, these are columns, first column, second column, third column, fourth column in the matrix. Here, the 1, 2, 3, 4 represents first row, second row, third row, and fourth row of the given matrix. The first value can be filled with the distance from 1 to 1. Always remember that all the diagonal values in the given graph should be zeros. That means that the distance from self vertex are 0. Here there are 4 vertices are there. 1, 2, 3, 4. The distance from vertex 1 to vertex 1 is 0. The distance from vertex 2 to vertex 2 is 0. The distance from vertex 3 to vertex 3 is 0. And the distance from vertex 4 to vertex 4 is 0. That means that, so all diagonals are to be considered as 0 weightage. Next, we need to find the distance from vertex 1 to vertex 2. Vertex 1 to vertex 2, there is a direct path with a distance of 8. So that's why I have marked as 8. And next we need to find the distance from vertex 1 to vertex 3. So there is no direct path from vertex 1 to vertex 3. Hence, we don't know the direct distance from vertex 1 to vertex 3. Hence, we need to consider this as infinity. So once again, I will tell you here vertex 1 to vertex 3. Vertex 1 to vertex 3. The value is considered as infinity. Why I am considering the value is infinity? Infinity means there is no direct path from vertex 1 to vertex 3. So that's why we can consider the given distance from vertex 1 to vertex 3 is infinity. And there is a path from vertex 1 to vertex 3 to an intermediate vertex is 2. This is considered as a intermediate vertex. Intermediate vertex. So here intermediate vertex is 2. But we need to find the distance from vertex 1 to vertex 3 directly. There is no path is exist. That's why I can mention as infinity. Next, find the distance from vertex 1 to vertex 4. So vertex 1 to vertex 4, there is a direct path is of weight is 1. So the first row is over. Next, fill the values of second row matrix in the given matrices and find the distance from vertex 2 to vertex 1. So if you want to find vertex 2 to vertex 1, there is no direct path exist. That's why we can consider as infinity is the distance. And these are diagonals. All diagonals are to be considered as zeros. All diagonals are considered as zeros. And vertex 2 to vertex 3. If you consider vertex 2 to vertex 3, the distance is 1. And vertex 2 to vertex 4, there is no direct path from vertex 2 to vertex 4. That's why I can consider as a infinity. So next, these two also over. First and second over. Next, we will go for third row. 3 to 1, vertex 3 to vertex 1. There is no direct path. There is a direct path exist from vertex 3 to vertex 1. vertex 3 to vertex 1 direct path exists. So that's why simply you have to mention the weight is 4. Total weight is 4. And next find the distance from vertex 3 to vertex 2. So vertex 3 to vertex 2, there is no direct path exists. That's why you can consider as a infinity. And vertex 3 to vertex 4, and vertex 3 to vertex 4 there is no direct path exist, that's why you can consider the path is infinity. So third row also completed. Next we need to find the distance from vertex 4 row, vertex 4 to vertex 1. So we do know there is no direct path from vertex 4 to vertex 1, there is no direct path, hence you can consider this one as infinity. And vertex 4 to vertex 2, vertex 4 to vertex 2 there is a direct path exist, the weight is 2. Vertex 4 to vertex 3, vertex 4 to vertex 3 there is a direct path exist of weight 9. Vertex 4 to vertex 4 there is no self loop, that's why we can consider the weight is 0. So friends, in this way, in this way you simply you simply prepare the initial matrix with the distance values that seems to be D0. D0 stands for preparing a matrix with initial distance values. Okay. Now the second step is now the second step. Sorry. Next one is here all pair shortest path. We need to find the distance among from one pair of vertices to another pair of vertices. Here there are four vertices are there, namely vertex 1, vertex 2, vertex 3, and vertex 4. Initially, we need to find the distance from vertex 1 to vertex 2, vertex 1 to vertex 3, vertex 1 to vertex 4. So, this is the first step. So the values, the shortest path we need to find, and that can be placed in the matrix of D0. That can be placed in the matrix of D0. Once we need to find the values, all the values, we can find the values in D of 1. So D of 1 is nothing but here. So we need to find the distance from 1 to 1, 1 to 2, 1 to 3, 1 to 4. Next, we need to find D of 2. D of 2 is nothing but a distance from vertex 2 to all remaining vertices. So consider vertex 2 is the starting vertex, and remaining vertices we need to find the minimum distance 2 to 1, 2 to 3, 2 to 4. Next, you can find the distance of D3. Distance of D3 you need to find. The distance of D3 from the given vertices to all the leftover vertices you need to find the minimum distance. Distance from vertex 3 to vertex 1, vertex 3 to vertex 2, vertex 3 to vertex 4 you need to find out. And next, we need to find the distance from vertex 4 to all remaining vertices, namely 4, 1, 4, 2, 4, 3. So in this way, we need to generate total 4 matrices from the given example. We need to generate 4 matrices, namely D1, D2, D3, and D4. D0 is to be generated from the given graph directly based on the initial values. Here there is no intermediate path exist. D1 means the intermediate path is vertex 1. Find the minimum route from vertex through the intermediate vertex we need to find. Here intermediate vertex is 2. Here intermediate vertex is 3. Here intermediate vertex is 4. So that means that we need to calculate the matrices of D1, D2, D3, D4 with the minimum values, distance values we need to find out respectively. Friends, there is a formula. If you observe the given formula, before discussing about the formula, we will discuss about a simple example. If you want to calculate the distance from, if you want to calculate the distance from one vertex I, another vertex G. If you want to calculate distance between I to J. So D of Ij will represent the distance from I to J. The distance from vertex I to J clearly represents D of Ij. So this direct path, the entire path is to be considered as a direct path. This is called as a direct path. Direct means there is a direct route or path exists from the vertex I to vertex J. So this is to be written in the formula as d of I comma j, which deals with the distance from I to j, which represents the direct path from I to j. Okay. Next means if you want to move from vertex I to vertex j through an intermediate vertex that is called as k. Here k is considered as intermediate vertex. K is considered as intermediate vertex. That means that K belongs to intermediate vertex. So K is an intermediate vertex which can be existing between vertex I and vertex J. There is a possibility of moving from vertex I to vertex J through an intermediate vertex that is vertex K. So in this case, how to calculate the distance is there is no direct path exists from I to J, but through a intermediate vertex K, there is a path exists. But how to find the distance here is first you need to calculate the distance from I to J. So I to K. Initially, you need to find the distance from vertex I to vertex K, and later on you need to find the distance from K to J. Vertex K to vertex J, you need to find the distance from. Next, you need to add the distance of vertex I to K and vertex K to J. Just you need to add the distance of both vertices I to K and K to J, and you will get the intermediate you will get the intermediate vertex. Through intermediate vertex, you will get the path from I to J. So here this formula will represents, this is the formula which represents d of I to k. D of I to k. So here clearly mentioned that there is a d of I to k and d of k to j. D of k to j. Clearly mentioned that. And d of I to k, you need to find the distance. Here k is intermediate node and d of distance from vertex k to j. Vertex k to j. So if you sum distance from vertex I to k and vertex k to j, you will get the sum of the distance between vertex I to j through an intermediate vertex k. And once you will get the value and you can compare the value with the direct path value. You will get two values. One is direct path distance, another one is intermediate path distance. Once you will get the values of direct path distance and intermediate path distance, and you need to find the minimum value, you need to find the minimum value among those two. You need to find the minimum value of direct path value and the minimum value of intermediate value. Which one is minimum, and that is to be considered as the distance from I to J. So friends, in this way, we can measure the distance from one vertices to another vertices through a direct path. We can consider a value, and through an intermediate path you can consider a value. Among those two values, you can select the minimum value or minimum distance value that can be considered as the distance from one pair to another pair in the given graph or matrices. So friends, I hope you understood this. Okay. Next, we will move to another slide. So we will discuss the problem with a simple example. Simple example. This is the given graph. This is a weighted directed graph. This is a weighted directed graph. Why I can consider this is a weighted directed graph? There is a weights. These are all weights. 1, 8, 2, 1. These are all weights. Why I am considering this is a direct graph? There is a direct path from 2 to 3. That's why we can consider this is a directed graph, weighted directed graph. So the given graph is a weighted directed graph. From the graph, I need to find all page shortest path from vertex 1 to vertex 2, vertex 1 to vertex 3, vertex 1 to vertex 4. So this is the first step. Next, I need to find the small shortest path from 2 to 1, 2 to 2, 2 to 3, 2 to 4. Next, find the distance from 3 to 1, 3 to 2, 3 to 3, 3 to 4. Next, find the distance from 4 to 1, 4 to 2, 4 to 3, and 4 to 4. So in this way, in each and every stage, you need to find the minimum distance in a pairwise manner. So initially, the first step is from the given graph, you need to prepare a matrix. The matrix initially starts with D0. D0 stands for distance. There is no intermediate vertex here. Simply we can place from the given graph, we can place the values into the matrix. So this is find D of 0. So once D of 0 is to be found, we need to prepare the matrix with initial distances. Next the task is you need to prepare the remaining three also. You need to prepare D1 matrix, D2 matrix, D3 matrix, and D4 matrix. If you consider D1 matrix, you need to consider 1 to 2 and 1 to 3 and 1 to 4 you need to find. If you consider D2 matrix, so you need to find the distance from 2 to 3, 2 to 4 and 2 to 1 also. If you consider the D3 means you need to find the distance from 3 to 1, the vertices 3 to 2 and the vertices 3 to 4. If you want to find the value of D4 matrix, you need to find the distance from vertex 4 to 1, vertex 4 to 2, vertex 4 to 3. So in this way, you need to prepare total 4 different matrices. So here the formula is, this is the formula. Find the distance from I to j. If you want to find the distance from I to j, consider this is I and j is 4. This is 4 is considered as a j. If you want to find the distance from I to j, you need to find the value is minimum of direct path. Initially, you need to find the direct path. So direct path means distance of 1 to 4. I value is 1 and j value is 4. You need to find it. And comma intermediate path. Intermediate path means through intermediate nodes you can move from vertex 1 to vertex 4. If there is a possibility of moving through intermediate nodes from vertex 1 to vertex 4. So you need to find the value of this one and you need to calculate the distance from direct path and indirect path values and which one is minimum. That minimum value is to be considered as the answer. So in this way we can prepare the matrices. Okay, friends. Once the initial matrix is to be generated, I have been kept the initial matrix in the topmost right corner. Next, I need to find the distance of 1. Find D1. So how to find the distance from one vertices to another vertices through an intermediate vertex is 1. So here the intermediate vertex is 1 is to be considered as intermediate vertex. Here 1 is to be considered as a intermediate vertex. It is called as a intermediate vertex. Intermediate vertex. So intermediate vertex. So here we need to find D1 value. D1 means find, prepare a matrix via vertex 1 as an intermediate vertex. So here first we need to find the values of 1 to 1, 1 to 3, 1 to 2, 1 to 3, 1 to 4. Assume that find the values of 1 to 1, 1 to 2, 1 to 3, 1 to 4. There is no change occurs in 1 to 1, 1 to 2, 1 to 3, 1 to 4. Why? Because the intermediate vertex is 1 and the starting vertex is 1. That's why the values may not be changed. The first row and first column values may not be changed in the given matrix. First row and first column are mentioned in a dotted line. Those values may not be changed if you compare D0 with D1. Why? Because the intermediate vertex value is 1 and the starting vertex is 1. Both are same. In this case, first row and first column values may not be changed. And we need to find the minimum distance among all the remaining states. Whether these are correct or not, we need to verify it. Next, we need to find the distance from 2 to 2. Find the distance from 2 to 2. That means that all uh, these are considered as a diagonal values. Diagonal values should be 0. And you need to verify whether these are correct or not. And find the distance from 2 to 3. So 2 to 3, if you want to find the distance from, if you want to find the distance from 2 to 3, 3 to 2, initially we will see 3 to 2. Distance from 3 to 2 we will see. We will see this one first now. So distance from 3 to 2. So now we are finding the distance from 3 to 2. Distance from 3 to 2, there is a formula how to calculate the distance from 3 to 2. So d of ij, I is 3 and j is equal to 2 here. I is 3, j is equal to 2. And minimum of direct path from 3 to 2, comma, intermediate path through vertex 1. Intermediate path from through vertex 1. That means that there is, you need to find, if you want to find the distance of 3 to 2, if you want to find the distance of 3 to 2, first find the direct path 3 to 2. 3 to 2 direct path you need to find, but there is no direct path from 3 to 2. So that's why the path from 3 to 2 is infinity. The path from 3 to 2 is considered as a infinity. And through an intermediate vertex we will try it. Through an intermediate vertex we will try it. There is no path exist from 3 to 2 direct, but there is a path exists from 3 to 2 through intermediate vertex 1. Through intermediate vertex 1, we need to find the path from 3 to 2. So that means that how to calculate the value here through intermediate vertex, d of 3 to, sorry, 3 to 1 and d of 1 to 2, d of 1 to 2. So first move from 3 to 1. What is the value? 3 to 1 value is 4. And the 3 to 2, 3 to the d of 1 to 2 value is 8. 8 plus 4, that is equal to 12. We will get the value is 12. So here, like that only, the distance from 3 to 1 is 4 and the distance from 1 to 2 is 8 and total value is 12. Now here we need to find the minimum of infinity comma 12. Which one is minimum is nothing but in 12 is minimum. That's why we can find the value of d of 3 comma 2 is 12. So d of 3 comma 2 value is 12. We have find the value of D of 3 comma 12 here. Next we will see find the distance of 3 to 4. 3 to 4. We will check whether it is correct or not. So here 3 to 4, the distance from 3 to 4 is initially 4. Why? Because there is no direct path exist from 3 to 4. That's why I can consider the value is infinity. So I can fill the values of infinity. Infinity values is to be replaced with minimum values in the initial matrix. So here, what is the value, minimum value? I need to compare and I need to replace the value. That is the main objective. If I want to find the distance from vertex 3 to vertex 4 through intermediate vertex, here the intermediate vertex is 1. 1 is considered as a intermediate vertex. Here vertex 1 is to be considered as a intermediate vertex. Now find the value of 3 to 4. So 3 to 4. So there is no direct path exist from 3 to 4. There is no direct path exist from 3 to 4. So the path is infinity. The path is infinity. So what is the another way of moving from 3 to 4? There is another way of moving 3 to 4 is first move from 3 to intermediate vertex 1 and then move from vertex 1 to vertex 4. So it will cost totally 4 plus 1, 5. So cost is 4 plus 1 is 5. Now compare 5 with infinity value and the minimum one is 5. And here the infinity value is to be replaced with the value as 5. So that's why 5 is to be placed here. Okay. Next, remaining all are there is no change will be done here. So here changes will be done in 12 and in 15 also. Here the changes will be done here only. So this can be replaced as a 12 if you move from D0 to D1. This is the initial matrix and this is through intermediate vertex matrix. If you observe the difference between initial matrix to the given matrix, two changes are made. The first one is if you want to move from vertex 3 to vertex 2, instead of moving direct path, you just move from 3 to 2 through intermediate vertex 1. Okay, so that is the good way. And if you want to move from vertex 3 to vertex 4 through intermediate vertex 1, the total size, the total cost is 5, not infinity. So two changes are made in this given graph. Okay, friends, now we will discuss uh, how to find D2. Now, this is the initial matrix we have been drawn from the given graph, and D1 we have been generated through intermediate x1. And now we will find in this slide we will find how to calculate the how to now here we need to find D2. That means that prepare matrix via vertex 2 as intermediate vertex. So here the intermediate vertex is 2. 2 is to be considered as a intermediate vertex. The main objective of this step is we need to find the minimum distance from vertex 1 to all the remaining vertices through an intermediate vertex 2. The main objective is find the smallest route from vertex 1 to all the remaining vertices, pairs through an intermediate vertex 2. Okay. Now we need to find D2. How we will see how to find D2. So here, if you want to calculate the minimum distance of D2, the second row, second column may not be changed. The values of second row and second column may not be changed. So if you observe D1 with the D2, second row values and the second column values may not be changed, and the remaining values may be changed. There is a possibility. So here we will consider the minimum cost of 1 to 3. This is a simple example 1 to 3. If I want to find 1 to 3, so the 1 to 3 I need to find the value, this value. So if you observe these two, d1 d2, if you observe these two values are changed. Why these two values are changed? Why infinity is replaced by 9? So because if you consider infinity with 9, 9 is minimum. The distance from vertex 1 to vertex 3 is 9, not infinity. When it is possible to the vertex 2, it is possible. Now we will see how to do that. Now see how to solve the minimum cost of distance 1 to 3. Vertex 1 to vertex 3 now we see. So now the concept is find the distance from vertex 1 to vertex 3. So how to find the distance from vertex 1 to vertex 3? Find the direct path, whether direct path existing from vertex 1 to vertex 3. First we need to analyze it. So, but here there is no direct path exist from vertex 1 to vertex 3. That's why the distance from vertex 1 to vertex 3 is to be considered as infinity. Is to be considered as infinity. Next one is find the distance from vertex 1 to vertex 3 through intermediate vertex 2. So, how to find through intermediate vertex means from 1 to 2 and next 2 to 3. In this way, we can find the distance from vertex 1 to vertex 3 through intermediate vertex 2. In this case, the total cost is 8 plus 1. The total cost is here 8, here 1. Total cost is 9. Now compare 9 with infinity and we will get the minimum cost is 9. So that means that if you want to find the distance from, if you want to calculate the distance from 1 to 3, so the best way of moving from 1 to 3 through intermediate 2, it will cost is 9. 9 is the minimum one. So now the value of 1 to 3, 9 is to be replaced with the infinity value. So that's why we will get the value minimum distance from 1 to 3 is 9 in this case. Okay. Next, find the minimum cost from 4 to 3. Fourth row, third column. Fourth row, third column. So check whether these two values. Here, the value 9 is to be replaced with 3. Now we will see how it is formed. That means that find the distance from vertex 4 to vertex 3. Direct path. Verify, analyze whether the direct path exists from vertex 4 to vertex 3. Vertex 4 to vertex 3 direct path exists. So the value is 4 to 3 is 9. And check whether through intermediate node is it possible. Vertex 4 to vertex 3 through intermediate path is it possible or not, we will see. There is a direct path exists from vertex 4 to vertex 3 through vertex 2. It will cost is 4 to 2, 2 to 1. 4 to 2 the value is 2 and 2 to 1 the value is 1. Total value is 3. Now compare the value 3 with the value 9. Which one is minimum? 3 is minimum. That's why the minimum cost is 3 is replaced here. So the matrix is to be updated and this is the revised matrix of vertex 2 through vertex 2. Friends, so in this way, we need to find the minimum cost in each and every row values by using the concept of Albert shortest path using dynamic programming. Next, we need to find the value of D3. Next one is D3. So now see whether, so this is the, sorry, this is the initial matrix D0. D1 we need to generate it. D2 matrix also generated. Now check D3 matrix here. How to generate the matrix D3 we will discuss now here. Okay. So here the intermediate vertex is 3. T is to be considered as a intermediate vertex. Now here, if you observe that changes made from D2 to D3 are will effective in two cases whenever we are finding the value of D of 21 and D of 24 and D of 41. In these three cases, the values are clearly changed. If you observe D of 21, the value infinity is changed here, and the value of 24 value also changed, and the value of 41 also changed. These three values are changed when the matrix updated from D2 to D3. So now we will see how the updations can be done here. Now first find the value distance from 2 to 1, how to solve the problem. So find or analyze, is there any direct path from distance from 2 to 1? There is no direct path exist from distance 2 to 1. No direct path exists. So that's why the direct path is to be considered as a infinity. And check through intermediate vertex 1, is it possible or not? Is it possible or not? So if you want to move from vertex 2 to vertex 1 through intermediate 3, is it possible or not? You will see. So is it possible? We will see. That is possible. How that is possible is, if you want to move from vertex 2 to 3, vertex 2 to 3, it will cost is 1. And if you move from vertex 3 to 1, it will cost is 4, and total cost is 4 plus 1, 5. So now compare 5. Now compare 5 with infinity. We can conclude that the distance from D of 2 to 1 is 5. The distance from vertex 1 to vertex 2 is 5 whenever you are planning to move from vertex 2 to vertex 1 through the intermediate vertex 3. The minimum cost is 5. Hence, the minimum cost 5 is replaced with the infinity value here. Replaced with the infinity value. So this is the first one over. Next, find the Next, find the distance from 2 to 4. Calculate the distance from 2 to 4 through intermediate vertex 3. Through intermediate vertex 3. Okay. So check whether direct path exists or not. Distance from 2 to 4. Distance from 2 to 4, there is no direct path exists. That's why we can consider it is infinity. Okay. So it is 2 to 4. Distance from 2 to 4, there is no direct path, consider infinity. Now, how to move distance 2 to 4? How to move from 2 to 4 through intermediate vertex, we will see. So there is a possibility of moving from 2 to 4 through intermediate vertex 3. How it is possible is 2 to 3, 3 to 1, and 1 to 4. So here through intermediate vertex we have been moved here. So if you move 2 to 3, 1, and 3 to 1, 4, and 4, 1 to 4, 1, total cost is 1 plus 4 plus 1, 5. Total cost is 5. So here now compare 5 with the infinity. The minimum distance from 3 to, 2 to 4 is 2 to 4 is distance from 2 to 4. Distance from 2 to 4 is 6, 4, 6, not 5. So this is 6. The total value is 6. So distance, we need to find the total value of distance from 2 to 4 is 6. Distance from 2 to 4 is 6. It is replaced with the infinity value. Okay. Next is we'll find the distance from 4 to 1. How to calculate the distance from 4 to 1? Check whether there is a direct path existing from 4 to 1. There is no direct path exist from 4 to 1. That's why it is infinity. And the intermediate vertex is 3. Through vertex 3, is there any way from vertex 4 to 1? We will find out. That is possible. How it is, we will see. So if you want to move from vertex 4 to vertex 1 through the intermediate vertex, there is two ways. The first one is moving from 4 to 3 and 3 to 1 is the way. So 4 to 3, 9, and 3 to 4, 4. Total is 13. We will get the value is 13. But check whether another way is possible or not. From vertex 1 to vertex 3. So from vertex 1 to vertex 3, we will see another way through vertex 3. We will see vertex 1 to vertex 4. And sorry, vertex 1 to 4 to 1. Find the distance from vertex 4 to vertex 1. Check whether it is, how we will get the value 7. 4 to 1. So the starting vertex is 4 and the ending vertex is 1. Through intermediate vertex is 3. Now we will see whether it is possible or not. Okay. Uh, 2, 1. Yeah. If you moving from 4 to 2, 4 to 2, then 2 to 3, then 2 to 3, then 3 to 1, then 3 to 1. What is the cost? 2, 1, 4. 2, 1, 4. The cost is 7. Another way is through intermediate 3. Another way is 1 to 7. You get the answer 7. The 7 is replaced here. Infinity is to be replaced by 7. So another way is 4 to 1, no? 4 to 3 and 3 to 1. There is a possibility. 4 to 3 and 3 to 1. If we consider this, what is the cost of 4 to 3? 4 to 3 cost is 9 and 3 to 1 cost is 3 to 1 cost is 4. The cost is 13. Now compare 13 with 7. Which one is minimum? 7 is minimum. Hence 7 is to be replaced with the infinity value. Hope you understood this. And the last at most one is find the value of D4. Friends, from the given graph, we have been created three matrices, namely D1, D2, D3 matrices. Here, there is no intermediate vertex. Here, vertex 1 is the intermediate vertex. Here, vertex 2 is considered as intermediate vertex. In D3, vertex 3 is to be considered as intermediate vertex. Now, find vertex 4 is to be considered as the intermediate vertex, and we need to prepare how to prepare the matrix. Here we will see. Friends, here vertex 4 is to be considered as intermediate vertex. Now we need to find 4 to 1, 4 to 2, 4 to 3. 4 to 1, 4 to 2, 4 to 3, we need to find the values. Now here, first find D of 1 to 2. D of 1 to 2. Find the distance from 1 to 2. 1 to 2. Observe here. Find the distance from vertex 1 to vertex 2. So vertex 1 to vertex 2 distance direct path is available. The direct path is 8. But check whether it is the maximum and minimum. If you want to move from vertex 1 to vertex 2 through intermediate vertex 4, through if you want to move from vertex 1 to vertex 2, there is two possible ways. One is directly move from one vertex 1 to vertex 2, it will cost the total size is 8. Through intermediate vertex, it may be possible from vertex 1 to 4 and vertex 4 to 2. Vertex 1 to 4 cost is 4, 1, vertex 4 to 2 cost is 2, and total size is 3. Now compare 8 with 3, you will get the value is 3. You will get the distance from 1 to 3. Minimum value is 3. Hence, this is the minimum value. This is to be replaced with the existing 8 value. Okay. Next, find the value of minimum distance from 1 to 3. Find the minimum distance from 1 to 3. Minimum distance from 1 to 3 through vertex 4. So 1, 2, 3. Find the minimum distance from vertex 1 to vertex 3. Check whether is there any direct path. There is no direct path existing, but there is through vertex 4 it is possible. Through vertex 4 it is 1 plus 9, 10. This is one way. Another way is another way is 1 1 to 3 direct path na. 1 to 3, sorry, 1 to, yeah, 1 to 3 direct path. So how it is possible is first 1 to 4, 1 to 4, then 4 to 2, 2 to 1, and then 3 to 1. Sorry, if you want to calculate the distance from 1 to 3, if you want to calculate the distance from 1 to 3, 1 to node 1 to node 3, you need to calculate the distance from 1 to 3. Find there is no direct path existing, so that's why you can consider that the direct path value is infinity. The direct path from 1 to 3 is infinity. Now find 1 to 4 also. 1 to 4, here to here, the first move, and 4 to 2 is the second move. Next move is 2 to 3. 2 to 3. That means that there is a possible of moving from vertex 1 to vertex 3 to the intermediate vertex 4. It is possible. It will cost is 4. The cost is 4. So hence the distance from 1 to 3, the cost is 4, which can be replaced with the cost of 9. Cost of 9. Why? How 9 is 1 to 2, 2 to 1 cost is 9. The cost is to be replaced with the minimum cost. Okay. Next, friends, we need to find the distance from 3 to 2. So this is vertex 3 and this is vertex 2. Find the minimum cost from vertex 3 to vertex 3. Observe or analyze. There is no direct path existing. So the distance from vertex 3 to 2 is considered as infinity. And the next step is move from 3 to 1. Move from 3 to 1 first initially. Once you reach 3, move from 1 to 4 also. Then move from 1 to 4. Once you reach 1 to 4, then move from 4 to 2. 4 to 2. So that means that the total cost is 4 plus 1 plus 2, 7. The total cost from vertex 3 to 2 is 7, which can be replaced with the value of existing 12 is to be replaced by 7 here. So friends, in this way, this is the final generated matrix, which can be clearly says that all pair shortest path from one pair of nodes to another pair of nodes through the intermediate vertices 1, 2, 3, 4 respectively. So hence we can conclude that this is the best example for finding the minimum cost from one pair of the matrices to the another pair of matrices. Okay, thank you. So I will explain the same program in a short way in the next class. Thank you. Thank you.